All right, lesson 8.2 is about central angles and perimeter. We're starting in your notes packet on page number 6. We're going to first just kind of go over some names of some different polygons so that you know what they are and you can actually use this like as a reference page for yourself. A triangle is going to have 3 sides. A quadrilateral is going to have 4. A pentagon is going to have 5. A hexagon is going to have 6 sides. A heptagon, which is sometimes also called a septagon with an S out front, is going to have 7 sides. An octagon has 8. A nonagon has 9. A decagon has 10. You've probably heard the word decade before, is 10 years. And a dodecagon is 12. Outside of those ones, we really just call them whatever number of sides they have. We put that in here, and then we put a dash, and then we put gon. So for example, if you had a 21-sided object, you would just call it a 21 gon, and that's fine. These are just the ones that have the names that we would expect you to be able to use. So what we're going to be talking about for the first part of this lesson is what's called the central angle. The central angle is what happens kind of if you think about a polygon as having a belly button. And I'm going to kind of show this to you in 1 second here. Let me actually go over here. So you have a lineup of shapes here. So I'm going to ask you on the triangle to go ahead and give the triangle a belly button right there in the center. And what happens is, in order to create central angles, you go from the center of that polygon and you draw a straight line out to each of the vertices that you have. So a triangle has 3 vertices. So we're going to draw straight lines out to all of them. And so what you've created here in the center are a set of 3 congruent angles. And they're congruent because for our triangles and all of our polygons here, we are assuming that these are what are called regular polygons, which means all the sides are the same. So when all the sides are the same and you draw those angles out to those lines out to all the different vertices, the 3 angles that are in here are equal to each other. What we saw in our angles unit was when you start at a spot and you go all the way around, you have traveled 360 degrees. So it should make sense to you that because we drew a triangle that has 3 sides, we drew those lines, we actually end up with 3 different angles. So in order to find the number of angles, we would do the degree of each angle, we would do 360 divided by 3, which would give us 120 degrees. When we do this on the square, you can go ahead and give it a little belly button. I'm going to cheat and use a line maker here. So we can draw a line to each and every single one of the vertices that are here. And that wasn't quite exactly center, and you'll kind of be able to see why, because in the square, we actually have 4 angles. So I would do the 360 degrees divided by 4, and that'll give me 90 degrees, which would tell me that each of these should, in fact, actually be a right angle. That's why you can see why I didn't quite place it centered there. For the pentagon here, we're going to go ahead and draw our belly button center here, and then we're going to go ahead and extend those lines out to each of the vertices. And you can do this in your notes packet as well. And you'll notice here that we now have 1, 2, 3, 4, 5. So we would take 360 degrees divided by 5, which is going to give us 72 degrees. For the last one, we have a hexagon, so we'll put the belly button in the center, and then we'll go ahead and we'll draw the lines out to all the vertices from here. And for the hexagon, which is a 6-sided shape, you'll notice we have 1, 2, 3, 4, 5, 6 of these central angles. So we'll do 360 degrees divided by 6, which would tell us that each one of those measures is going to equal to 60 degrees. That brings us back to this box that was just up above these shapes. So anytime you have a central angle of this regular polygon, you take 360 degrees and you divide by n, where n stands for the number of sides of the polygon. And here's your note again. If you're talking about a regular polygon, which is what we're using here, all the sides are going to be exactly the same length. So these are pretty easy problems here. Biggest thing you need to know is how many sides does the polygon actually have? What is the measure of a central angle of a triangle? So a triangle has 3 sides, so you'll do 360 divided by 3, which we just witnessed up above was 120 degrees. Measure of a central angle of a hexagon is going to be 6, so we're going to do 360 degrees divided by 6, which will give us 60 degrees. Take a second. How many sides do you see on this polygon? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides would be correct. So you're going to take 360 degrees divided by 10. What's the measure of each central angle on this polygon? 360 divided by 10 is going to give you 36 degrees. So each central angle is worth 36 degrees on this decagon. That's the first part of our lesson. So the second part of our lesson is to talk about perimeter for today. So we're going to go ahead over to page number 7, and perimeter of any shape is going to be the outline. So to find the perimeter, you add up the lengths of all the sides on the outline of the shape. Units here are what we call linear units. So they're just inches, centimeters, feet, yards, miles, etc. It's one-dimensional, and you can think about it as being able to be measured with a string. When I think about perimeter, I'm thinking about a string. I'm also thinking about a Sharpie. A lot of times when you're doing a project, you'll want to grab like a darker colored marker, or a lot of times I've been asked for lots of Sharpies over the years to outline an item. So when you think about perimeter, think about the Sharpie. We're going to count the perimeter on these shapes. So we're just going to count the outside blocks that we have, the lengths here. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So my perimeter we're going to show with a capital P is equal to 16, and we don't know what our units are, so we're just going to call it units. Go ahead, take a second, count the perimeter on this second shape. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So my perimeter is equal to 18 units for this one. These are just kind of some block shapes that we can look at here. They are polygons. They are shapes for us to be able to look at. We're going to see a lot more common ones here moving forward, so we're going to look at some of those right now. Regular polygons, keep in mind, all the sides are the same. So if we know one side of a regular polygon, we can actually calculate the perimeter quite easily. For this one, I'm going to count the sides. 1, 2, 3, 4, 5, and 7. So n is equal to 7. Remember, n is the number of sides. So 7 sides times 10 inches here. So 7 times 10 would be 70 inches. For this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. As for this one, n is 10. 10 times 6 is going to give me 60, and my units are yards. This one is a pentagon. It has 5 sides. So I'm going to do 27 times 5, and that's going to give me 135 feet. For the next round, we're going to work backwards. If you have regular polygons and we know the perimeter, we can find the side lengths by dividing. So for this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 sides. If our perimeter is 60, we're doing 60 divided by 10, and that tells us that each side is 6 yards. For this next one, count up the number of sides. 1, 2, 3, 4, 5, 6, 7 is your sides. So if your perimeter is 84, you're going to go ahead and divide by 7, and that gives you 84 divided by 7 gives you 12 for each side. So you're going to have 12 feet for each side here on this example. A couple more basic ones. These are just regular shapes on page 8 that we're going to be looking at. We're going to have a lot of these kind of moving forward, and we're going to be working with a lot of these shapes in the future. We are going to just go ahead and add up our numbers here. In your notes packet, I'm going to ask you to err on the side of caution. Make sure you write everything out. On a quiz, please keep in mind, if you do not write out what you've added down and you accidentally add incorrectly, unfortunately, there's no way for me to give you partial credit. So my recommendation is just to go ahead and write this down. So I have 35 plus 32 plus 32. That's all my sides. Capital P for perimeter, which you should always be writing down. 35 plus 32 plus 32, I get 99. My units stay linear, so they're just going to stay inches. In this example 8, we have a rectangle here. Something you need to know about rectangles is that the lengths and the widths are going to be equal to each other on both sides. So something that we can do as kind of a quick little shortcut is we could do 2 times 30 plus 2 times 60, and that is going to end up giving me 60 plus 120, which is going to be 180, and my units are inches for this one. For example, number 9, again, you can use that little shortcut, 2 times 2 and 5, 6, plus 2 times 1 and 2/3, and you are able to use your calculator here if you would like to. So 2 times 2 and 5, 6, is actually going to, I'm going to break this down. We get 5 2/3. And 2 times 1 2/3 is going to give us 3 1/3. So if I add those two together, I'm going to end up with a total of 9 inches. For example, number 10, we have a trapezoid here. I'm going to add those 4 sides together. So we have 2 plus 7 plus 12 plus 6. Sometimes I'll mark the one where I started just so that I can kind of keep track of everything. So adding those all together, I get 27 yards. Just like we talked about when we first identified triangles, when you see those tick marks, it tells you that those sides are all the same. I do notice there are 4 of them that are 6 centimeters each, plus the 2 sides that are 10. So that's going to give me 24, plus another 20 is going to be 44 centimeters here on example number 11. 2 more examples for you in this packet for today. We are going to look at these. So we have some kind of crazy shapes. These are called rectilinear because they're basically made up of rectangles. So they are going to have some symmetry here. So what we can look at is if this side is 3 yards, we can also know this side is 3 yards. We're missing this piece right here, and this side's 4 yards. We can add in this side's 4 yards. So to find this piece, we actually have to do a little work. We have to realize that the whole entire bottom here is 4. And we have to realize this part's 1 and this part's 1. So these are going to be equal to each other. So this part is going to be equal to 2 yards. So what I'm going to do is I'm going to actually trace my shape and then actually write down the numbers as I go just to be able to keep track. So perimeter is equal to, so I have 1 plus 4 down this side, plus 4 across the bottom, plus 4 up this side, plus 1 across the top, 3 down, plus that 2 that we had to figure out, plus the 3 going up here. If I double check, I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 numbers. So it looks like I'm in good shape there. 1 plus 4 is 5. Actually, I'm going to do this a little easier. 4 times 3, that's 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I have 22 yards for that one. I look at this other, what we call rectilinear shape. We do have most of these sides. We're missing the bottom here and then also this little piece right here. Whole side is 25. I've already used up 15, which tells me 25 minus 15. This part's going to be 10. Across the bottom part, the whole entire thing is 20. I've already used up 15, so 20 minus 15 is going to leave me with 5. Figuring out my perimeter as I go around, I'm going to start here. I have 25 plus the 20 plus that 15 plus another 15 plus 10 and plus the 5. Real quick, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Ooh, okay, so we have 25 plus a 20 plus a 15 plus a 15 plus a 10 plus a 5. That's going to give us a total of 90 inches on that one. So that's your lesson about central angles as well as perimeter.